Yeah, Angelina.
Do 10 over 1.
10. These are two different points, though. So this is an x value and a y value, x value and a y value. If we're doing, you guys said rise over run, right? Was how you found the slope in the graph. How could I find the rise looking at a table? The y's, yeah. So with going from 10 to 8, what did we do? Subtract to 2. And then going from our run then would be the x value. So what did we do going from 1 to 2? Added 1. So our slope would be our rise over our run. Okay, sticking with slope for a minute, what else can we determine about slope, or what are some two types of slope that we could have? What are two different ways a line could look? Yeah? Vertical, horizontal, okay, cool. So if we have vertical and horizontal, if I could spell it, until. So if we have a vertical line in a graph, it would look like a vertical line. It's not a tricky one there. Or a horizontal one would be a horizontal line. What about the equation of a vertical line? I think Callie had one on her list. What did the equation of your vertical line look like?
Well, I had x.
Yeah, x equals, whenever it's x equals some number, that's the equation for a vertical line. So if x equals is for vertical, what do you think the equation for a horizontal line would look like? Yeah, just y equals some number. So these vertical and horizontal lines are where we don't have any other variables. It's just either x equals a number or y equals a number. So in a table with our vertical line, if you look at our graph here and our equation, it's saying that x is going to equal, like we'll say -2, so it kind of matches our graph here. If x equals -2, is there any other option for a value that x could be, or does it just have to be -2 the whole time? It just has to be, yeah, it's a vertical line. The only x value it's ever going to have is -2. It'll have a bunch of y values as it goes up and down, but the only x value will be -2. So if we had a table, it would just be -2 for everything, and then some y values. Everything would be -2. Then on the flip side, with our horizontal line, it would kind of be the opposite, where the y value would just be the same, but the x values will change because it's at the same y value for the whole time as it goes straight across. So our whole y values, they would all be 2, 2, 2, or whatever number it is, and our x values would change. So we have vertical lines and horizontal lines. What are some other options for the slope of a line? What's like the in-between part from vertical and horizontal? Diagonal, yeah. And what types of diagonal lines? Like, is it, this is one. What is this line doing as it goes from left to right? Rising or increasing. So what's the other option? Decreasing. So we can have increasing or decreasing. So we'll do those in two different boxes here, increasing or decreasing. Increasing, sometimes we also call it as positive. And then decreasing is also negative. So in a graph, with your arms, can you guys show me what you think an increasing slope would look like? Okay, wait. You're doing it from your point of view? Yeah? Yeah, okay, yeah. So it should be down on the left and then rising as you go from left to right, yeah. So increasing as you go left to right. That's how you could identify a positive or an increasing slope on a graph. If we had an equation, so y equals mx plus b, if we had this equation here, how could we determine what type of slope our line had just by looking at the equation? How could we know if it was positive or increasing? The m, what about the m? Yeah, the m is positive. And then what about in a table? So if I have some x values, like 1, 2, 3, 4, what would my y values have to be doing in order for me to know that it's a positive or increasing slope? Huh? They'd be increasing, yeah. So we go like 10, 12, 14, 16. Y values are increasing. Okay, so then with our decreasing or negative slope, it's basically all of the opposite here. So when we have our graph, our line would be decreasing as you go from left to right. In our equation, if m was a negative number, that would tell you we have a negative slope. And then for our table, if our y values were decreasing, that would tell us we have a negative or decreasing slope. All right, so we did a lot with slope, which is good. But one more thing I want to touch on. We had this equation y equals mx plus b. We dealt with the m. What does the b mean? The y-intercept, yes, on our back side here. Oops. So if I was looking at a graph and I had my line, how could I find the y-intercept, or how could I tell what the y-intercept is? Yeah, Angelina. Yes, wherever the line hits, whatever the point is on the y-axis that the line crosses. So crosses the y-axis. Okay, so in the equation, you guys said it was that b value that tells us what our y-intercept is. But now, a y-intercept on the graph there, that's a point, so it needs an x and a y value, but b is only one number. So is this b the x value or the y value of the y-intercept? The y value, what's the x value? 0, right? Because it's right on the y-axis, so it's not going left or right at all. So this is our y-intercept. It's the point 0, b. Okay, so then in a table, if I was trying to find the y-intercept looking at a table, what could I look for to help me identify it? Where x is equal to 0. Oops, where x equals 0. Okay, so y-intercept is one. Is there another type of intercept that we deal with when we're looking at lines? Give you a hint, there's an x and y axis, so there's probably a y and x intercept, yeah. X-intercept. So on our graph, how could I find the x-intercept on a graph? Yes, so our cross is through the x-axis. Now in our equation, if we were sticking with our y equals mx plus b here, is there anything in the equation that tells me what my x-intercept is right off the bat? No, but is there a way I could figure it out? Yes, how? You can, in your calculator? Is that what you're saying? Yeah, you could use your calculator to help you. Or you're saying plug something into the equation? Angelina? Did you say plug something into the equation? Is that what you meant? Okay, plug what into the equation? Yeah, so you need to know the slope. You need to know the y-intercept. So you'll have those m and b values. How could we find what the x-intercept is, though, then, from that equation? Yeah, how far over it is on the x-axis. And so just looking at the equation, though, if we have our graph on the x-axis, what's the y value of that point? 0. So if you plug in 0 for y and solve for x like we were doing on our quiz yesterday, then that could give us our x-intercept. So plug in 0 for y and solve for x. And so for our table, if I was trying to find my x-intercept, what would I look for? Yes, when y is 0. All right, so this is giving us a good start. We have a lot of stuff dealing with slope on our front side here, and then we have a little bit with our intercepts. Is there anything else that you guys have on your list here that you remember about lines that you would like to share? Angelina, yeah?
There's different quadrants with different negatives and positives.
Yeah, different quadrants, that's helpful. Is it ANT? Quadrant, I think so. So if we have our coordinate plane here, you guys remember how to number these quadrants? One is the top right, one is positive and positive. And then is 2 this one or this one? Left or under? What? It's left, yeah, it goes counterclockwise. So 1, 2, 3, 4. So this could be a helpful way to identify lines or where a line is placed. Like if we look at our example, or the example I sketched right here, this line does not go through quadrant 2 at all. Quadrants, there's no real way to identify them just by looking at the equation and the table. It's mainly going to come from your graph, being able to look at the graph. So we'll leave those 2 boxes blank for right now. Is there anything else you guys had on your list that you want to share? Okay. So then if we look at the bottom here, I give you a line, graph of a line, and I just want you to tell me some things about this graph. So what's one thing that you guys notice about the graph? You can use like the words and the vocab that we just went through to kind of help you identify some stuff. Yeah, Taylor. It's decreasing. Good. All right, what else? What's something else? Yeah, Tyler.
Intercepts at point 0.
Yes, there's a point at 0 at the origin there. Goes through the origin, which is the point 0, 0. What else is that point 0, 0? The y-intercept and the x-intercept. Yeah, when it goes to the origin, it counts for both of them. So the x-intercept is 0, 0, because y is 0, which is how we find the x-intercepts, and the y-intercept is 0, 0, because x is 0, which is how we find the y-intercept. Cool. All right, we know the slope is decreasing. Can we get more specific with the slope? Okay, yeah, what quadrants does it go through?
2 and 4.
Uh-huh. Quadrants 2 and 4. Can we find the value of the slope? Yeah. How could we do that? So we have our graph. Y equals mx plus b is the equation, but we don't know any, yeah. Huh? Rise over run. So you need 2 points. We found the origin already, which is one of them. So you just find another nice point where it crosses at a nice value. At x equals 4? Ooh. Oh, this one. So rise, right, that's the up and down. So we go 1, 2, 3, 4. Down, so minus 4. And then our run is we're going to the right. So 1, 2, 3, 4, 5. So then our slope, again, you said is rise over run. So it would be, our rise was negative 4 over our run, which was a positive 5. So this would be our slope. So now we know the slope and we figured out what the y-intercept is. So now could we write this equation for the line? Yeah, I'd have y equals, what would my m be? The negative 4 over 5 that we calculated with our rise over run. So negative 4 over 5 x. The x is always attached to the slope there. And then what would I add at the end for that b value? Yeah, plus 0. So if you want to write 0, just so you're always writing something, that's fine. But technically, if you add 0, it doesn't change anything. So you could just write it as y equals negative 4 over 5 x. All right. Good. So this idea here where you're looking at graphs and trying to determine information about it is what we're going to be doing in the Desmos activity.